All right. We're in section 10.7 where we're going to write and graph equations of circles. So we can actually represent any point on a circle with the center at the origin here, 0, 0, and has a radius of r. We can use the Pythagorean theorem to find the equation of a circle. So if we go and say, all right, the Pythagorean theorem was a squared plus b squared equaling c squared. So what we have here is a right triangle with one leg as x, so we'll call that a. So this is going to be like x squared plus the other leg of this right triangle is a value of y, so we'll call this y squared. And it's going to be equal to the hypotenuse, which we'll represent as the radius, r, so this is r squared. So anytime we have a circle that is in the center of our coordinate plane, it can be represented by x squared plus y squared equals whatever the value of r is squared. So if you look at this one right here, I need to find the radius. So the radius is going to be 1, 2, 3, 4, 5, 6, 7. So it's at 7. So r is 7. So the equation for this circle is going to be x squared plus y squared equals 7 squared. So to figure this out, it's going to be x squared plus y squared equals 49. Now there's going to be some instances where we have circles where their center points are not on the origin. Anytime they're not on the origin, the standard equation for a circle for that particular characteristic when they're not in the center is going to be x minus h quantity squared plus y minus k quantity squared is equal to r squared. So the r squared stays the same. Now we have some things that we have to write in for h and k. H is going to be the center point of our x coordinate, and k is going to be the center point of our y coordinate. So if we look at these three circles here, looks like the center for this top one in the first quadrant is 1, 2, 3, 4. So 4 comma 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. Okay. And then over here, that's the center points in quadrant 2, negative 1, negative 2, negative 3, negative 4, negative 5. So I got negative 5 comma 1. And then here I have 1, 2, 3, 4. So it's going to be 4 comma negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7. So we got the center points. So like if we call this circle A, call this circle B, call this circle C. So to find the equation for circle A, it's going to be x minus 4, because it's the opposite, quantity squared, plus y minus 5 quantity squared is going to equal to the radius squared, which is 1, 2, 3. 3 squared is 9. For circle B, it's going to be x plus 5 quantity squared, because it's the opposite, plus y times the quantity of y minus 1 quantity squared is going to be equal to the radius, which is 1, 2, 3, 4 squared, which is 16. To find our equation for circle C, it's going to be x minus 4 squared, quantity squared, times by the quantity of y plus 7 quantity squared is equal to 1, 2. 2 squared is 4, and so that is my equation of those circles. So here they're asking us to write the standard equation of a circle with a given center and given radius, very similar to what we did on the previous page. They just give you the information rather than you have it on a graph or coordinate plane. So since the center is 0, 0, I know that's going to be x squared plus y squared, because, x minus 0 is just going to be x, and y minus 0 is just going to be y. So that's why we can just write it as x squared and y squared, and it's equal to 12 squared, which is 144. The second one, it's going to be x minus 4 quantity squared plus y minus 9 quantity squared is equal to 3 squared, which is 9. C, it's going to be x plus 7, because again, it's the opposite, quantity squared plus y minus 5 quantity squared is equal to 18 squared, which gives us 324. And the final example in this little step here, it's going to be uh, x squared, because it's 0, plus the quantity of y minus 4 squared is equal to 5 squared, which is 25. Okay. So in this particular example, they're asking us to use the information to write an equation for um, the circle. So we know that the general formula is x minus h squared plus y minus k squared is equal to r squared. They give us a center point, which is our h and k. They give us a point on the circle, which is helpful because we don't know what the radius is. So we need to find the radius. So basically what we're going to do is we're going to substitute these values in for x and y into this formula, and substitute these values into h and k into the same formula, and then solve. So what we're going to get is 7 minus 2 squared plus y is negative 8 minus a negative 3 squared, and that's going to equal r squared. This is going to be cross the line, change of sign. 7 minus 2 is 5. 5 squared is 25, so I got 25 right here. Plus negative 8 plus 3 is negative 5. Squaring that, we get 25. So now I got 25 here, which equals r squared. 25 plus 25 is 50. So we don't necessarily need to find the radius. We just need to find the radius squared because we're asked to find the equation. So the equation for this is now going to be x using minus 2, because that was the value of h squared, plus y plus, not 8, it's going to be 3, y plus 3 quantity squared is equal to 50. So this is the general equation for this information, because if we were to plug 7 and negative 8 in, we'd get 50. Okay. The final step here is we need to determine whether this equation defines as a circle, and if it does, write it in standard form. All right, this is a little bit challenging, but we'll go by it step by step. First thing we got to do is we got to get all uh, constants on the one side of the equal sign. So I'm going to add 10 to both sides. So that gives me 38 on the right hand side. After that, I want to have all of my variables next to each other. So I'm going to have x squared minus 6x, and I'm going to have plus y squared plus 8y, and that's going to be set equal to 18 plus 10, which is 28. So what we're going to do here is I'm going to look at these and these two individually, and we're going to kind of go back to what we did in intermediate algebra and say, all right, we want to complete the square. So I'm going to take x squared minus 6x plus 6 is my negative 6 is my b. Negative 6 divided by 2 is 3, and negative 3. Negative 3 squared is 9. So that is my perfect square trinomial for there, plus y squared plus 8y plus 8 divided by 2 is 4. 4 squared is 16. And then it's going to equal 28. But because I added a 9 and a 16, I got to add 9 and add 16. Me adding the 9 and adding the 16 comes from that formula of let me write it a little better. X squared plus bx plus b over 2 quantity squared, which then gets written as x plus b over 2 quantity squared. So now this turns into the square of a binomial, just like here. This turns into x minus 3 quantity squared plus this turns into y plus 4 quantity squared, and it's going to be equal to 28 plus 9 plus 16, which gives you 53. And this looks like an equation of a square where your center points would be 3 comma negative 4, and then our radius would be whatever the square root of 53 would be. And that is how you write in graphs or equations of circles. Hope this helps. Until next time.